Let's practice. Topic 15, Video D, multiple choice.
To begin this problem, we would first set up an equation, which would be CXHYOZ plus O2, which would give us CO2 plus H2O. If we're given 0.293 grams of CO2, we want to find out the grams of carbon in the sample and the moles of carbon in the sample. To do this, we would find the percent composition of carbon in CO2. So we would divide 12.0111 grams of carbon, which is equivalent to 1 mole of carbon, by 44.01 grams of CO2, which is also equivalent to 1 mole of CO2, and then we would multiply by 100, which would give us 27.29%. Then we would use this value to find the grams of C in the sample. So we do 0.2729 times 0.293 grams, which would give us 0.079 grams of carbon. Step 3 would be to find the moles of carbon in the sample. So we would do 0.079 grams of carbon divided by 12.011 grams of carbon, which would give us 0.0066 moles of carbon. We would then repeat this problem in the same way, but now with H2O. So we'd find the percent composition of H and H2O. So we would do 2.0158 grams of H over 18.01 grams of H2O multiplied by 100, which would give us 11.19%. Then we would want to find the grams of hydrogen in the sample. So we would do 0.1119 times 0.120 grams, which would give us 0.013 grams of hydrogen. And then we would want to find the moles of hydrogen in the sample. So we would do 0.013 grams of hydrogen divided by 1.008 grams of hydrogen, which would give us 0.0129 moles of hydrogen.
To recap what we found, we have 0.2 grams of a compound containing 0.079 grams of carbon and 0.013 grams of hydrogen. The next step is to find how much oxygen we have in this compound. To do that, we subtract the mass of carbon, 0.079, and the mass of hydrogen, 0.013, from the mass of the compound, 0.2, giving us 0.108 grams of oxygen. The next step is to find how many moles of oxygen we have in the sample. To do this, we take the grams of oxygen we just found and divide it by the formula weight of oxygen, 15.999 grams. We then get 0.0068 moles of oxygen in the compound. Now that we have the moles of oxygen, carbon, and hydrogen, we can compare the mole ratio of each element in the compound. To do this, we divide each amount of moles from the smallest amount of moles, being carbon with 0.0066 moles. We then receive a mole ratio of 1 carbon to 2 hydrogens to 1 oxygen. Our empirical formula is CH2O.
Number 2 is also a combustion problem. We will begin by figuring out the grams of carbon and moles of carbon in the sample. Since there are 1.9 grams of carbon dioxide in the sample, we will begin by finding the percent composition of carbon in CO2. We divide 12.011 grams of carbon by 44.01 grams of carbon dioxide and multiply our answer by 100 to get 27.29%. Step 2 is to find the grams of carbon in the sample. We multiply the percent composition, 0.2729, by the mass of CO2 in the sample, 1.9 grams, to get 0.5185 grams of carbon. Then we have to find the moles of carbon in the sample. We divide 0.5185 grams of carbon by 12.01 grams of carbon to get 0.0432 moles of carbon in the sample. We repeat this process for hydrogen. Since there are 1.072 grams of H2O in the sample, we begin by finding the percent composition of H and H2O. We divide 2.0158 grams of hydrogen, because there are 2 hydrogens in H2O, by 18.01 grams of H2O, and multiply our answer by 100 to get 11.19%. Then we find the grams of H in the compound. We multiply the percent composition, 0.1119, by the mass of H2O in the sample, 1.072 grams, to get 0.1199 grams of hydrogen. Next, we find the moles of hydrogen in the sample. Divide 0.1199 grams of hydrogen by 1.008 grams of hydrogen to get 0.1189 moles of hydrogen in the sample.
To recap what we have 0.9835 grams in the compound and the mass of carbon and hydrogen in the sample. With this information, we can find the mass of oxygen by subtracting the grams of carbon and hydrogen in the sample from 0.9835 grams, and you get 0.3451 grams of oxygen. Then, we have to find the moles of oxygen in the sample. We divide 0.3451 grams of oxygen by 15.999 grams of oxygen to get 0.0216 moles of oxygen. Now that we have the moles of oxygen, carbon, and hydrogen, we can compare the mole ratio of each element in the compound. To do this, we divide the moles of each element by the smallest mole, in this case, oxygen, with 0.0216 moles. We then receive a mole ratio of 2 carbon to 5.5 hydrogen to 1 oxygen. Empirical formulas need to contain whole numbers. Since hydrogen is 5.5, we have to multiply everything by 2 so that hydrogen can be 11. Our empirical formula is C4H11O2.
The answers.